Welcome to Star-Oddi's tutorial. In this video, we'll go over the use of the HAT Analyzer software. It is a great tool that will help you navigate, process, and validate your ECG data. By the end of this tutorial, you will know how to upload, process, and validate your data and view the modified results. Let's dive in. We'll begin by going over the software installation. If you've already installed it, feel free to skip to the next chapter. Go to the Star-Oddi website and click on the Software button in the Support menu. You'll see all our software options here. Click on the HAT Analyzer to download it. Once downloaded, open the installation file and follow the installation steps. Then open the HAT Analyzer and start working with your data. For additional help and guidance, you can open the user manual by clicking on the Download User Manual button in the corner. Next, we'll go over how to upload and save the data. First, set the source folder where the data you want to validate is stored. Here I have an example folder. In the typical Mercury file structure, you have multiple files in the logger folder. However, the HAT Analyzer software only works with DAT and HAT files, so you'll only see those files displayed. The DAT file contains data such as the logger's heart rate and quality index, among other variables. The HAT file contains raw ECG data. For instance, in this example, measurement number 2354 includes raw ECG data. Here I have plotted first ECG record. The heart rate is calculated using the RR interval of the ECG waveform. That is, the time elapsed between two successive R waves. These are converted files based on what you have done inside Mercury, like quality index elimination. You can find older conversion files inside the sequence number folder. In this case, I have only the original file, which is marked with 0 in the beginning. However, if you previously reconverted the data in Mercury, you'll see those files here as well. Next, set the working folder, where the modified data files will be saved. It can be the same folder as the source folder or a new one. Finally, set the filter folder, which contains filters that are used to process the ECG records. This folder should always be the Mercury filter folder. Now I should have some HAT files available. I'll select the original file with 0 at the beginning. Then I'll select the first recorded ECG and load that record. Now we have selected the data to work with, and we can start processing it. Once you have loaded the record, you can navigate the data. Use these buttons to move between ECG records and save each record with this button. Or create hotkeys for faster use by pressing the question mark. If you have the DAT file in the source folder, you'll see the logger calculated heart rate and quality index here. This particular record shows a calculated heart rate of 36 and quality index of 0. As you work with the data, you'll also see the computer and user calculated heart rates, heart rate variability, and quality index. You can process this data by pressing the built-in filter, and the software highlights the filter that you should be using. After selecting a filter, you process a single record or the entire file. Here you can see how the computer algorithm detected the QRS waveforms. It assigns peaks to the biggest slope of the QRS waveforms, where the most significant difference is between 2 points, so not necessarily on the absolute peaks. The computer annotated data also gives us 36 beats per minute but in addition, it calculates heart rate variability, both the SDNN and RMSSD values. The computer and logger should match, but older loggers might show slightly different heart rate and quality index. On the right-hand side, you can see the processed data after it has gone through the bandpass filter. The waveform can change significantly depending on the animal model and the filter file used. Now that we have processed the data, let's move on to validate each record. You can manually annotate the record by pressing the peaks of the QRS waveform to get an absolute detection. You can see that it also gives 36 beats per minute and very similar heart rate variability values. If I press S, I save the manually annotated peaks and can go to the next record by pressing D. For faster manual annotation, validate the computer annotation and save them as your user's peaks by pressing S, without marking any peaks. To add or reject peaks, make those changes and press S again. Here are some examples of ECG records that need adjustment. This record has one erroneous peak that should be excluded. To fix this, I press S, then exclude the peak and press S again to save the change. In the next example, the filter has only selected one peak, while the other peaks were rejected. This requires a manual annotation. I'll manually select each of the peaks. The last peak isn't an obvious QRS waveform, but it follows the same rhythm as the others. You can choose to either include or exclude it. It won't significantly affect the heart rate, but it will impact the heart rate variability. Finally, in this example, the computer's annotation can be validated, and one extra peak is rejected. Again, excluding this peak won't change the heart rate much, but it will have greater impact on the heart rate variability. Now the data has been validated and regulated, let's view the updated data. You can save the changes to enhanced DAT file, either with beats per minute and quality index values, set by the user or calculated by the HRT Analyzer when the records are processed, by pressing these buttons. Or you can use the files automatically saved inside the working folders. Those files only include the records with saved ECG. The protobuf file is used by the analyzer to calculate data. Other files can be opened with a text editor, Excel, R, or other preferred software. The CQI files include heart rate and quality index for user or PC annotated records and can be compared to the RQI file from Mercury. The UCL file combines all information from the user, computer, and logger. Then there are 3 HRV files, one for user annotated records, one for computer annotated data, and one combining both. If user annotations exist, those records are placed instead of the computer annotated records. Check the user manual for further descriptions of these files. I'll go over the user PC HRV file, as it's the most commonly used. You can plot the heart rate and heart rate variability. Here you can see the plotted variables and the high spikes in the heart rate variability plot. Those are probably erroneous values, and those records can be investigated further. You can also see the average amplitude and the number of QRS waveforms used for the calculation. Thank you for watching this tutorial. If you have any questions or need additional help, please refer to the user manual or email us.